Alright, let's take a look at another example, a rational inequality. So remember, our first step, let's go ahead and start looking for those critical values. So remember, we're going to find the undefined value first. So let's see where this rational function would be undefined. And of course, we know we're undefined when our denominator is 0. So again, let's look for that. Undefined values. Any undefined values would be, again, a critical value. So x minus 2 cannot equal 0. Right? If our denominator is 0, we know, again, would be undefined. So 2, and that's it. The only undefined value we have. Now, if we're looking at that, again, we can put it over here on this x line. Right? So let's go ahead and place that on here for 2. So if I put 2 over here on the x line, we know our graph is going to go vertical there. If we were looking at it graphically, this would be the location of our vertical asymptote. If you remember back to our rationals, right? The zeros of your denominator, again, locate your vertical asymptote locations. But that's a break in this. That's going to form an interval in a little bit, help form one. Now we also need to find the solutions, right, to the related equation. Solve the related equation. Let's find the solutions, the zeros, right, which would be our location of our x-intercepts graphically. So let's take this function, so 4x minus 5 over x minus 2, and related equation, right, we can set it equal to 3. So just drop the inequality symbol, put an equal sign, and let's solve it. Now as we're solving this one, since it's equal to 3, we need to go ahead and clear out this fraction. So let's multiply both sides by x minus 2, the LCD, right? We have multiple rational terms. We would find a common denominator, least common denominator, and multiply everything by that, both sides of the equation, so we can divide out the denominators and clear the fractions. So as we do that, what does it simplify to? So we're looking at our function now. We've got 4x minus 5 equal to 3 times x minus 2. So we multiply both sides of the LCD. So let's solve the linear equation. So now we've got an x out of the denominator. Let's go ahead and distribute. 3 times x, 3x, 3 times negative 2, negative 6. And we'll go ahead and get the x terms by themselves on one side. Let's go ahead and subtract the 3x. We'll go ahead and add the 5, right, to the right side. So we end up, after we simplify down, with x, right, equal to negative 1. X equal negative 1 as we found our solution to the related equation. So again, you can check if you plug negative 1 back in the beginning, right, it should equal 3. 4 times negative 1 is negative 4. Negative 4 minus 5, negative 9. Negative 1 minus 2 is negative 3, right? Negative 9 over negative 3 is 3. So it checks. But that's the solution to the related equation. So solve the related equation. So any solutions from that. So we found x equal to negative 1. So that's a critical value. So again, our critical values are our solutions to the related equation and any undefined values, which is 2. So let's go ahead and put negative 1 on here. So negative 1, which would be over here, and this would be an x-intercept location if you were graphing it. But what does it do with our intervals? So we got these intervals to test, right? We got to, again, look at the possibilities for solutions. So with that said, we can test the interval from what? Negative infinity to negative 1, less than equal to. Put a bracket on that because we do have equality in this problem. So we want to remember that with this problem. Or we can be greater than or equal to negative 1 and less than 2. Now we don't want a bracket, on 2 because that's undefined value. And then, of course, from 2 to infinity. So we need to test those. Those are our test intervals, right? So our solution sets, what we have, we're going to come from these. So we're going to pick a test value. So let's look at our test values, put in a different color. So negative infinity, negative 1. Negative 2 would be an easy one to test with. Right, 0 and 3, those would be some numbers. You only need one. Pick one, test it. If it works, they all work. If it doesn't, none of them work. So let's see if negative 2 is in the solution set. It won't take long. Let's plug that in. 4 times x, 4 times negative 2, minus 5 divided by negative 2 minus 2. Is it greater than or equal to 3? That's our question. Well, what do we get when we simplify? So 4 to the negative 2 is negative 8. Negative 8 minus 5 is negative 13. Negative 2 minus 2 is negative 4. Is that greater than or equal to 3? That's 13 fourths. 13 fourths is 3 and 1/4. Right? We write it as a mixed number. 4 goes in 13 3 times with 1 left over. Well, that's greater than 3. True. We want it to be greater than or equal to 3. What is? So that's a solution. So we need to include that in our solution set. Now, how about negative 1 to 2? We need to test it. So let's plug in 0. Let's see if it works. 0 is our test value. Any number greater than or equal to negative 1, less than 2. So 4 times 0 minus 5 divided by 0 minus 2, is that greater than or equal to 3? Well, we simplify, we get negative 5 or negative 2. That's 5 halves. Well, 5 halves, that's what, 2.5? That's less than 3. That didn't work. So we got to get rid of it. None of those work. So we got to exclude that interval from solution set. And our last possibility, how about 3? Do we need to include 2 to infinity in our solution set interval? Let's find out. Plug in 2. 4 times, actually plug in 3, I'm sorry. Test value is 3. 4 times 3 minus 5 divided by 3 minus 2. So out went x and went our test value of 3. Is it greater than or equal to 3? Well, 4 times 3 is 12. 12 minus 5 is 7. 3 minus 2 is 1. Yes, 7 is greater than 3. True. So again, there's 2 intervals that worked when we plugged in our test value. And that's at, what, all values less than or equal to negative 1, and also all the x values greater than 2. So we can conclude now our solution set interval. So our solution set will be all x values less than or equal to negative 1, or all x values greater than 2. So again, we've solved a rational inequality, finding those critical values, setting up the test intervals, picking a test value, and testing them. Testing the original inequality. Hope that helps.